Hello guys, and welcome to sixth part of TinyOS tutorial. In this part I'm going to show you how to actually use the onboard sensors on TelosB, or you may apply the same procedures for other sensor boards and read from the sensors. In this case I'm going to use the temperature sensor on the TelosB to capture the temperature of environment and send it to a PC using the serial port, and let's see how it goes. So I'm going to find my Eclipse, should be somewhere here, and start a new project and get writing the code. Okay, I think you remember the procedure right now. I'm going to make a new project. Going to name this project. First, let's select the TinyOS type. Then next, the project name will be temp test, and our target going to be TelosB. And yeah, that's pretty much everything you need to make a new project. Going to add to the source folder a module file. The TinyOS project is being initialized, so we have to wait for it, like 28%. It usually doesn't take too long. So anyway, yeah, 90, 100%. Okay, I'm going to add a new module file and name it temp test C. This was our convention for naming module files. Okay, now it's time to start coding. In the module file, I'm going to define the interfaces that are necessary beside the general interfaces like boot and timer and LEDs. We're gonna need to use read interface, but first let's define the general interfaces. I'm going to say interface boot timer of simile type. Interface timer. Then we need interface LEDs. So when we're doing something, we're gonna use the LEDs to indicate if something is going on well or going on wrong. LEDs. And now, okay, let's comment this part as general interfaces. Read. So I'm going to just normally say interface read, and the data we are going to read is of type unsigned int 16, and we're gonna name this as temp read, temperature. Okay, so that's pretty much everything we would need. But of course, if you want to add the interfaces of wireless communication, for example, you want to take the temperature from one mote or sensor board and send it to another one, then you normally would use interfaces related to that, but this is not our case now. But we're going to just read the temperature and send it to serial port. So I'm going to add the events that are missing from the boot and the timer And read interface also has some events, and one of them is read done. And when the reading of a sensor is being done, then the read value will be come to this event, and we can do something with it. We need to convert it actually to a real world number, and I'm gonna show you later how. Okay, let's start with the boot event. So in the boot event, what we would need is to set up our timer. And yeah, just let's say start periodic. Okay, let's say we want to take a reading every 1 second or 1,000 milliseconds, and we want to turn on one LED to indicate that the sensor is running. So we start with the LED 1. LED 1 is the green LED on TelosB, so we can use it to say the sensor board is on. And then in the timer event, what we're gonna do is ask the sensor to take a reading and give us the value back. So for that we're gonna need to call a function, a command or function through inside the read interface. So what I'm gonna say is call temp read read. Okay. So what this command does is ask the sensor to take a reading, and when the reading is done, it will passes the reading through this event. It's named read done. It means the reading has been done by sensor, and we now can extract the value out of this argument, the value that passes here. But this read command has a return value, success or failure, as you would say. So what we have a chance here to check if the reading was actually done or not. So we can put this inside the if statement, and we can say if this call was successful. Let's say we want to light up a LED to indicate that we are reading a value from the sensor. So let's say call let's start LED 2 on, or toggle letter. And if not, we're gonna indicate that there was something wrong. So I'm gonna say let's that LED 0, that is the red LED on TelosB. LED 0 toggle. So quite simple. When the timer fires, we ask the read interface to take a reading from the attached sensor, and that is something we have to do in the configuration file, and I'm going to show you very soon. And from the when we do this call, if the reading was successful, then we end up in this event, and now we can extract the value out of the sensor. So for that I'm gonna do a simple use a simple conversion formula, but first do it in just with the raw ADC values. Okay, when this event fires up, it will passes to us two values, a result and a value. So first we're gonna check if the result is a successful action. Now we can let's just temporary right here. Now we can read sensor value. Else there was a problem. And for using probably this is something new for you, for using the writing text into the using the USB of TelosB, you're gonna need to use a printf function. And how to do that is basically quite very simple, but first I forgot something. We had to include the timer header file. Then we need to include CDIO and also include the string header. So maybe you're gonna do some string conversion or something when you're going to write into the serial port. And let's come here. Let's say the read down event returned a successful action or type. Then we're gonna simply say printf let's say current temp is, we're using a placeholder, as the is the val. And if it was not successful, we're gonna do we're gonna print out error statement. Error reading from sensor. Okay, let's have a quick overview. So we included the necessary headers: timer, stdio, and a string. Timer for timer, obviously, and stdio and string is for using the printf function. And we just defined three general interfaces: boot, timer, and LEDs. When the sensor board is getting booted, we start the timer with a periodic function of 1000 milliseconds or 1 second, and we turn on one LED, the green one on TelosB, to indicate that the sensor board is on. And every time that the timer is going to be fired, we ask the read interface to do a read on the attached sensor that we're gonna define in the configuration file very soon. And while the sensor is taking a reading, we light up LED 2, and if the sensor is busy or something, we light up the LED 0. And when the sensor is returning us with a value, if the action was successful, we're gonna just write into the serial port current temperature is %D. This is the placeholder for float values. And if there was something wrong with the sensor, we're gonna write error or something. So we are done with the module file and now going to define the configuration file. So the convention was project name followed by appc. Okay. Now we're gonna do the introduce components and do the wiring. So let's say these are the general components. So we had the actual module file, components, yes, components, main C, let's see for boot and using the LEDs. Then we have the timer, components, new timer, millisec. Okay. Now we're gonna do the basic wiring. Actually, the boot event, boot interface. You have to wire it to main C. Wire it to main C. After LEDs, we of course have to wire it to LEDs, and the timer we have to wire it to the timer that we have defined. Okay, and for using the printf function, we have to include another component, and that's for writing into serial port. Components, serial, printf C. So this component is a little bit funny. You shouldn't do wiring. You just need to add this line to your configuration file, so the compiler knows to use this during the compilation. So if you see the Yeti plugin shows an error, just don't mind it. It's not an error, and it should be there. Otherwise, you cannot write into the serial port. Okay. Now the interesting part is for the temperature sensor, and the temperature sensor on TelosB is of type from the Sensiron company, and its name is SHT11. So if you look into the TelosB folder in TinyOS, you will find the necessary files for it. But for now, we're just gonna write it like this. So components, Sensiron. This is the component that you need to use. I'm gonna say it as temp sensor, and of course you have to add the parentheses because it's a generic one. And now for the wiring, it's quite easy. You just need to say temp read should be wired to temp sensor dot temperature. So this is a and don't mind the error, we're gonna fix that also. temp sensor. Okay, and that's pretty much everything that we need. We have an error here. I'm not sure what is it, but probably from the Yeti plugin. But we're gonna compile the program and see what can be the problem. But for now, let's just add the make file. Make file. So in the make file, we define our main component that should be compiled is test app temp test yes, temp test app C, the configuration that we need to compile. And for using the printf function, we also need to use this directive. We need to ask the compiler to find the necessary files in this folder. Test.ir. It's actually in the lib folder, the library, and printf. Then including the make rules. That should do it. So in the make file, we define the main component that should be compiled, and because we're gonna use the printf function, we're gonna call the compiler to look into the library folder and find the necessary files, and we just include the make rules. That's done, and let's go and compile the program and see if it works. So going to my worker space, we have it on a folder named temp test. Going to source folder, list of files, everything is there. And let's make a build, make TelosB. Okay, it says cannot find a temperature. It was the same error that we had here. Yes. Apparently I had a syntax error while writing the temperature. So the temp sensor, if you move your mouse over it, if the the temperature sensor on TelosB is not only for reading the temperature. You can also do humidity also. That's something we're gonna add after we successfully read the temperature, and I will show you how to read from many sensors almost simultaneously. Now let's go back to the compiler and see if the error is gone. Oh, apparently we didn't save the file. Okay. We have an error here. So on line 22, cannot find temperature. Let's see what's the problem. Yeti doesn't show us any problem. Maybe we have to clean it. Cannot find a temperature. Okay. Let's see what can be run. So apparently because of a problem with Eclipse, the file wasn't saved. So I'm going to save the file using the menus. It's quite annoying. but let's try again. Okay, now we have the compilation was successful, so I'm going to clean it and actually install it on a real board. So let's see if I have attached any TelosBs to my PC. Mote list. Okay, we have the one TelosB at TTY USB 0 port, so I'm going to give write access to that port and install the program. Okay, the program is installed on the TelosB, and for watching the output, you're gonna need a serial terminal program like the one I'm using, and its name is serial port terminal. So inside the Ubuntu, if you go to Software Center, you can search for serial port terminal and you will find it. And let's change the configuration. The port that you are using is TTY USB 0, and the baud rate that TelosB uses for writing serial port is 15,200, and the parity is none, and 8 bits, stop bits 1, and flow control none. Okay, you can see that you are getting some readings, and of course this is the value that you are seeing is raw data from ADC, and we have to use the conversion formula that we can find in the datasheet of the sensor. So let's make this a little bit more clean. I'm going to close the serial port, and let's go back to our module file. What we can do to make it look better, so we're gonna write this on new lines every time that we take a reading. So we have to use backslash R and backslash N. That is a carrier return and a new line. Same for this one. And for the conversion, I have the conversion on top of my head, but if you want to exactly convert it to real world temperature, then you're gonna measure the voltage to the MSP 430 chip, because the conversion formula is a function of the voltage that you're using for your ADC pins. And for example, if you're running on battery and the battery is going low and low during time, then the conversion formula should be corrected for that. But because now I'm using the USB port, so I'm going to getting a constant voltage. It's not a big deal. So if I remember correctly, the conversion rate, what we're gonna do, to do something with the the conversion rate, I'm trying to remember it. It was minus 39.6 plus 0.1 times the actual value that the raw data. This is the conversion formula. So I'm going to save the files and do compile again. Yes, no problem so far. Okay, now I'm going to open the serial port again, the terminal, do the configuration again. You can save the configuration. I'm gonna show you. So remember the port that your TelosB is on, and the baud rate 1115 1200, and the parity none, 8 bits, stop bit 1, and flow control none. Okay, I'm gonna save this configuration for later. Okay, there's probably something wrong here. Let's go and fix it. But first, let's save the configuration for the serial port, so we don't have to do it every time. Okay. Going back to Eclipse. So we did the conversion, but for some reasons I couldn't see it on the serial port. So I'm going to try again. Maybe it's another time a problem with Eclipse that didn't save the file. Going to install it again. And yeah, we're getting a funny value. Maybe we have to do conversion somewhere else. Gonna quit from the serial port. So let's define a value here. Let's say unsigned int centigrade if it was in C, normal C, it would work, but apparently we have to do it wait, so we have to do the conversion here. Centigrade will be equal minus 39.60 plus 0 times val. And remember, the val was the value of the sensor that the read done event of the read interface is throwing back at us. So this time I'm gonna okay, and save all. Install again, and this time should work. Okay, yeah. It was So current temperature of my room is 28 degrees, and if I put my tip of my finger on the sensor, the temperature should rise and you should be able to see it. So I'm doing it right now. You can see because the my body temperature, the sensor is getting hotter, and you're getting up to 30 values. And if I remove my finger, it should go back to the ambient temperature. It's currently 30 degrees. And you see it's going down again. So this indicates that we are reading the sensor correctly. And let's stop the serial port here. And I told you that I will show you how to read from multiple sensors. And let's add the humidity value also, or let's make it a bit more complicated. TelosB also has a light sensor that can measure the luminance of the light in the environment, and let's use that sensor this time. So I'm going back to the module file. The first thing I have to do introduce another interface, another instance of read interface. And this time I'm gonna call it light read. And again we have to define the events. Okay, you see we have another event from the read interface, but this time is being called from the light read interface. So what I'm gonna do during the timer, I will do the same thing that I did with the temperature. So this time, instead of using the temp read, I'm gonna say light read. And going to copy and paste the same thing, but inside the event for the light read. And I'm gonna edit this. Current light is and instead of centigrade we're gonna define something else. Unit 16T. This time luminance. And I think the conversion for luminance was a little bit more difficult. I think it was 2.5 multiplied by the value we get divided by 4096. If you are using a 4 or 8-bit ADC, it's going to be important to know, times 6250. So it was 2.5. Okay, and instead we're gonna put it here, luminance. So for the light read event, we're gonna type out this one, and you have to go back to the configuration file, and this time for light component. And the components for light sensor on TelosB is from Hamamatsu, and if you go to the TelosB folder in your TinyOS, you will see the files, and you can read through them and see what's going on inside them. It's Hamamatsu's S1087 TSRC, and I'm gonna name this one as light sensor. Gonna do the wiring for light sensor. App.lightread. Should be wired to light sensor. And it's different with the temperature sensor because this sensor uses some internal components. For the temperature sensor, we had to use the dot directive to access the temperature part. If you wanted to access the humidity, you could use the humidity, but let's go with temperature. But for the light sensor, it's only for light sensor, and you don't need to do anything. So I'm saving the file. I'm going to compile it again. It's been compiled. And if I run the serial port again, see light is 0, temp is 28. So there's a problem here because light is for sure not 0, because my room is quite shiny right now, so there should be a problem in the code, and let's go back and fix it. So the problem may lie here. Maybe there's a problem with the conversion formula that I'm gonna check. Okay, yeah, because we forgot to add point zeros to our numbers, then by default it will be converted to an integer. So that's something to take care of. So luminance is 2.5 times the value of the sensor, actually within this parenthesis now, divided by 4096, then multiply by 62,050, 6,250. This is the right conversion formula, so I'm going to test it again. Playing the serial port again. Okay, now you see that the light is now okay. So if I put my finger on the light sensor and block the light from going inside it, so we have to see the light value to decrease. So it's now 156. Okay, you see I put my finger and I'm blocking the light, and the light is like 15. The unit is lux, I mean. Luminance is okay, and I remove my finger and you can see we're getting light to it, 160. Okay, this indicates that our temperature and light sensor is working fine. And to sum this up, and in this part of the tutorial we learned how to read from the onboard sensors of TelosB, and it should be quite similar to the other sensor boards. Just if they are using different sensors, then the components that you have to look for, you have to go to the respective folder of each sensor board in TinyOS and find out which sensors they are using. And if you want to make this more interesting, you can use like 2 or 3 TelosBs or sensor boards, and try to add some wireless action here. For example, read from one sensor and send it to another sensor board and write it into the serial port. And for that, if you have followed the part 5 of the tutorials that I made, I showed you how to use the wireless how to say that, wireless things, how to set up the wireless communication. Yeah, I hope that you have enjoyed this tutorial, and if you have any question, you remember that you can go to my website and my forum and ask your question there. And my site was simply sorry for the slow computer, eetutorials.com. So if you had any questions, go to eetutorials.com and go to the forum and ask it there. So hope you have enjoyed this tutorial, and till next tutorial, keep yourself busy, and as a homework, try to do the sensor reading inside the network. So see you later.